Okay, we've written the slope deflection equations, and now it's time to write the equilibrium equations. Nothing particularly new here, but there are a couple little details to make sure you pay attention to. So we substitute in MBA and MBC, and coming from that joint equilibrium, of course we're getting those equations from our slope deflection equation, and since that's MBA and MBC, and I've written these two right next to each other, we're just summing then that second line and that third line here together, and that's where we're coming up with this particular equation. Simplify it down, and we've got 56b plus 18c minus 5d, and I've taken the 38.4 to the other side. That's our first equation, right? And just to emphasize that again, this is that top left joint, and so we only have those two member end moments that are framing in, and so those two have to then sum to 0. And quite clearly that means one is in one direction, the other is in the other direction, with the same magnitude. Same thing over here at C, that we've got those two moments, they have to sum to 0, substitute in, simplify down, and you have then this expression for that second equation, 18b plus 76c minus 20d equals minus 57.6. Not at all surprising that there is a symmetry here involved in the b and the c term, the off diagonal term. The b in, or this 56b and then the 76c would not necessarily be the same because of the fact they probably won't be because of the asymmetry in the overall structure. As well, you have to be a little bit careful when you think about this symmetric matrix that we might be creating, because you never know if this equation is in effect been multiplied by something, and so you have to be a little bit careful in checking that symmetry of what will turn out to be the stiffness matrix later on. Right? So that's just a little aside. Write the two equations, substitute them in, and those one each for the rotational degrees of freedom. But now we need one for the sway. We've done this before. Make sure you draw the complete free body diagram of the structure. Here's our applied member load of 80 kilonewtons. And the only thing about the reactions that I've got shown here that you need to be consistent with from earlier work are the member end moments, because we have declared a particular sign convention, and these reactions are consistent with those member end moments. But the AX and the DX and the AY and the DY, we can choose to do in whatever direction you want. It's the first time we've shown them. It's only when we go to the member free body diagram that now we do have to be very careful to be consistent between those series of free body diagrams. Right? So we'll go ahead and put those end shears on, and then we put the member end moments in their positive direction, not the way we think they're physically acting or guessing, but the positive sign direction. And that gives us the two member end moments. I haven't shown the axial forces because we're not going to really need them for this work. Do the same thing over here for the other member. And let's go ahead and get the height of the column in as well, so that when it comes to doing the key work, which is we come back over to this left one, and what we find out is that AX is going to be equal to the opposite of DX, and then we come to this one, we say, okay, we can get AX in terms of the member end moments by summing moments up here at the top. So note that that will tell us that minus 6AX is going to be equal to the sum of MAB plus MBA. And for this other one, a similar fashion, some moments about the top, and we'd find that minus 3 times DX is equal to then the sum of MCD plus MDC. Right? Substitute those two into this expression here. On the left hand side, of course, that would be AX is equal to then all of this divided by the minus 6, so MAB plus MBA all divided by the 6, but the opposite of that. And then we come over here, the minus dx, well, then we just divide by 3, so we got MCD plus MDC divided by 3 for that one. From which, then, we can clear out the 6. That will be 6 over 3, so there's a 2 there. Take these all to the other side, and you would get that 0 equals MAB plus MBA plus 2 times MCD plus 2 times MDC. And if we then go back to our slope deflection equations, there's your MAB, that's 10B minus 5D. Your MBA is 20B minus 5D. Your MCD is all the way down here at the bottom, so that's 2 times 40C, so 80C minus 2 times 20D, so that's 40D. And then the second one here is going to be a 40C minus then a 40D. Right? Add all those up, and we'll have then that 0 is equal to 30B and then plus 120C minus 10, and then that's a 90D for our total, for our third equation of equilibrium that we'll use in the next step.